There are two simple smoothing techniques used in time series data. The first is the moving average, and the other is what I'm going to demonstrate in Excel today, and that is the exponential approach. So, to calculate our exponentially smoothed series, there's a few characteristics to note with the first few observations. So our observations from our exponential approach, we're going to illustrate with LT. And this data set is the number of calls that arrive at a call center over a 21-day period. It is the service calls data set. And for the first observation, it's just equal to the first observation in the data set. So 309. But then we use our value for alpha and the value of alpha subtracted from 1, our exponential elements, to maybe try to do better predictions than we could in the moving average approach. So in this scenario, we are using an alpha of 0.2, so 1 minus alpha is 0.8. I'm just going to go way over here and put that in a cell. So alpha is going to be 0.2 today. 1 minus alpha is going to be 0.8. And what's nice about this is that I can change these if I want to, and it's all going to be hard baked into the equations. So here, my second observation is that day's estimate plus that day's estimate times alpha plus the prior day's estimate multiplied by 1 minus alpha. So R1 is where we're holding our alpha value. Multiply that by today's observation, and then to that we will add R2 multiplied by our first observation, and we get an estimate of 305.6. And now I promise the last time the rules in the equation changes, for the third observation, we will multiply alpha by that day's estimate plus the prior day's estimate. So in this equation, we're looking at the actual call volume that day and yesterday's estimate. And I'm not sure that's terribly intuitive, but that's what we're working with, and it's just fine. So let me punch that in. R1 multiplied by that day's estimate, or not that day's estimate, that is y, that is the observed number of calls that day. So that is the observed value, but then we're going to multiply R2 by the previous day's estimate, and we get a value of 301.28. Copy that, can paste it all the way down, and you have the whole set. Alternatively, you can go to the data tab, go to data analysis, and go to exponential smoothing, and just note moving average is hanging out down here too. So I'm going to open up exponential smoothing. My input range is going to be calls. The damping factor is that 1 minus alpha. So in this case, my damping factor is 0.08. And then I can change my output range to give me my output here. And look what happens. There is the that's the moving the exponential smoothing with a damping factor of 0.8 done for you in a few clicks. Anyway, so actually with the way I set that up, I should have had the cell paste to D2 because that first, when we're talking about observed values, and note that it changes when you copy it. So I'm going to delete this and we'll redo that exponential smoothing and change that output cell. Oh, don't want solver. So now I want it to output in D2. And these are our observed or estimated values. So these are our estimated values. So this is y hat. That first value is NA, and then there is a 1 day lag for the estimated uh, versus the observed values. So let's just, for general interest, or call this estimate because it's about to go into a table. Let's highlight these and let's put them in a chart. That doesn't seem quite right. This looks like it'll do the trick just nicely. So this chart shows us the number of calls versus the estimated number of calls. And what we can see is that the number of calls is illustrated in blue, and our estimate is highlighted in orange. And we can see that it does not have the same highs and lows observed in the calls. It takes a very smooth average point through the data set. So we see that it is substantially smoother, which is perhaps a little bit easier for a shop owner to use to forecast purchases, for example. Now, to evaluate this, we still look to our MSE, MAD, and MAPE. So we do want to calculate the value of the error, which is the observed value, and then subtracted from that is our estimate. So little e for error, and what this is going to be is the number of calls, and then that subtracted by the estimated value. So that's minus 17. I'm going to copy that and drag it all the way down. So the MSE requires the sum of the squares of the error divided by the number of observations in the data set. So we're going to square our error here. I'm going to call this column E to the power of 2. E3, that's our error, raised to the second power. I just think it's kind of cute that the error column landed in column E. I mean, it was bound to happen. It was the 5th thing, but seeing it, I don't know, kind of makes me laugh a little bit. So then we'll sum our squared errors here. And then we can divide that value by our number of observations, which in this case is 20. So there is our MSE. To get the MAPE, or the MAD, although the MAPE also requires it, we want to take the absolute value of our error now. In Excel, this is done as ABS. We'll take that original value of the number, copy it down. We're going to do the same stuff. And so when we sum them all together, we get 258. And then if we divide that by the number of observations, we get 12.91. And then finally, to calculate the MAPE, we want the absolute value of both our observed and values and our error term. And we don't need to worry about it too much because all of our values for calls are positive. But if we had negative values in our observed column, we would have to be very careful to take the observed value. So here we're looking at basically the absolute value of the error divided by the observed values. So here our error is in G3, and we can divide that by B3. So here, because the error is always going to be a good bit smaller than the observed values, or it often will be, we end up with a bunch of very small numbers, but we want to sum these values. And then with these, we want to, again, multiply by 1/20 or divide by 20. So in this case, we want to multiply this value by 1/20 and then multiply it again by 100 to get the percentage as opposed to the ratio. So here we find the MAPE to evaluate this model. So we can look at the visualization, we can look at our MSE, MAD, and MAPE. And evaluate your exponential smoothing approach from there. So give it a shot with the service calls data and let me know if you have any questions.